Our next lesson on atomic structure and nuclear decay is on the concept of isotopes. Taking a look at the learning targets here for our standard. In the last video we worked on identifying and describing the subatomic particles. In this lesson we will be working on two of the learning targets. We want to work on defining the terms mass number and isotope. In the previous video we already worked on atomic number. We will really not get to the valence electron term yet. That'll be in a future video. We're also going to work on using proper chemical notation for describing atomic structure. So a question to consider. Are atoms of the same element identical? So I want you to consider two carbon atoms. Take a look at your periodic table, find carbon on there. You'll see that it is atomic number 6. Must those two atoms, must they be identical? Absolutely the same, meaning they have the same number of all the subatomic particles within them. We know they're both carbon atoms, but do they have to have the same number of protons, the same number of neutrons, the same number of electrons? Because they're both carbon, they both must contain 6 protons. That has to be the case, because if they didn't have 6 protons, they would not be carbon. Assuming that both the atoms are neutral, and for our purposes as we start to learn about atoms that will always be the case, they both have to have 6 electrons as well, because those 6 electrons will cancel the charge of the 6 protons. Recall the protons are positive, the electrons are negative. But what about the neutrons? Do they have to have the same number of neutrons? The answer to that question is no. They don't have to be identical. They could be. They very much could contain the same number of neutrons. They don't have to be. This brings up the term isotope. Isotopes are atoms of the same element, so like we have here, 2 carbon atoms. The same element, but they have different numbers of neutrons. Here's a picture for us to consider this idea. We actually have 3 different carbon atoms here. Each of them is an atom of carbon because they all contain 6 protons. That's what these red particles are to indicate. If you count those up, you'll see that there are 6 protons in each, and you can see that's listed as such below here. But the blue particles, those represent the neutrons in the nucleus. You'll notice the first one has 6, the next one has 7, the next one has 8 neutrons. So they're all carbon atoms, but they are not identical because they have different numbers of neutrons. So these we would all say are different isotopes of the element carbon. So how do we differentiate between these isotopes then? How do we know which isotope we're talking about? The one with 6, the one with 7, the one with 8 neutrons. Well, actually you can kind of see that in the picture here. Notice this first one is labeled carbon 12, the next one's labeled carbon 13, the next one's labeled carbon 14. Let's take a look at what those numbers represent. So isotopes are differentiated by their mass numbers, and that's what these numbers here, the 12, the 13, and the 14, that's what those are. Those are the mass numbers of those isotopes. So let's look at how we arrive at those mass numbers. A mass number is simply the number of protons plus the number of neutrons that are in the nucleus. So notice for this first isotope, I have 6 protons and 6 neutrons. 6 plus 6 is 12, so thus that is carbon 12. Its mass number is 12. For the second isotope, we have 6 protons plus 7 neutrons. 6 plus 7 is 13. And then lastly, we have carbon 14 because we have 6 protons plus 8 neutrons, and 6 plus 8 is 14. Note, these mass numbers are not on the periodic table. If you look at the periodic table, the one you guys have, you are not going to find mass numbers because there are multiple isotopes of most elements, and the individual mass numbers of each isotope are not listed there. These mass numbers, the term mass number is a little bit misleading because it's not actually the mass of the atom. It's close, but not exactly. The reason why it's close, recall, protons and neutrons are both right about 1 AMU. So for example, if we have carbon 13, 6 protons, that would be about 6 atomic mass units. 7 neutrons, that would be about 7 atomic mass units. 6 plus 7 is obviously 13. The mass of a carbon 13 atom is about 13 atomic mass units. It's not exactly that, but it's close. So let's look at some examples of how we determine the mass number of an atom. So for each of these, let's just figure out what the mass number is. So let's look at a nitrogen atom with 8 neutrons. So look at your periodic table, find nitrogen, it's towards the top there on the right side. You'll see it is atomic number 7. So remember, that means it has 7 protons. So the mass number then is 7 protons plus 8 neutrons. That gives you a mass number of 15. So how we would indicate that, if we were writing out in chemical notation, there's 2 ways we can do it. We can do it kind of like you see up here in the example, the picture. We can write out the entire name of the element, nitrogen, then we put a dash, and then we put the mass number of 15. We would just read this as nitrogen 15. We would not say nitrogen dash 15. We would just read it nitrogen 15, and we know we're talking about the nitrogen atom with a mass number of 15. In other words, having 8 neutrons. The other way to write it is with using the symbol, and you can see that here. Notice on the periodic table, the symbol for nitrogen is the capital letter N. And then we make the mass number a superscript on the left side. So on the top left-hand corner of the symbol there, we would write the mass number of 15. This you would also just read as nitrogen 15. So if you were reading either of these in text, when you got to them, you would just verbalize that as nitrogen 15. All right, let's look at another one. An atom with 24 protons and 30 neutrons. Well, here we're just straight up told we have 24 protons. So 24 protons plus 30 neutrons is 54. Look at your periodic table, figure out what element that is. So you'll notice that is an element, or that is an atom of chromium, because chromium is atomic number 24. And so note, we're not looking for atomic number 54. That's not what we're looking for here. We have 24 protons, so we want the atomic number 24. So that's chromium. And this would be an atom of chromium 54, because 24 protons plus 30 neutrons gives you 54. So again, you can see the 2 ways of writing it there. And then one more example. Find sodium on your periodic table and figure out the mass number and write the symbol for the sodium atom with 13 neutrons. So you can see sodium, the symbol is Na, it's towards the left side there on your periodic table. Its atomic number is 11, so 11 protons plus 13 neutrons, that gives you 24 for a mass number. So if we were to write that out, we could either just write the name sodium and the dash 24. Again, we would just read that as sodium 24, or we can use the symbol with that superscript notation there on the left side for sodium 24. Let's consider a different question here. So let's consider the isotopes of chlorine 35 and chlorine 37. So I have 2 atoms. One of them is a chlorine 35 atom, the other one's a chlorine 37 atom. And here we can see what the box for chlorine might look like on the periodic table. So some questions considering these atoms. Which atom has more protons? Well, they're both chlorine, and so neither of them does. Because they're both chlorine, they both have to contain 17 protons. Notice the atomic number for chlorine is 17, and so both atoms, the fact that they're different isotopes makes no difference. Because they're both chlorine, they both have 17 protons. Next question, which atom has more electrons? Well, again, if we assume that both atoms are neutral, which we said would be the case here as we start to learn about atoms, then they both have to have 17 electrons as well, because those 17 electrons will cancel the charge of the 17 protons. So both atoms, both the chlorine 35 and the chlorine 37, will have 17 protons and they will have 17 electrons. Lastly, which atom has more neutrons? Here you might be thinking, well, they're the same, they're both chlorine. But remember, we have different isotopes here. One chlorine 35, the other chlorine 37. So chlorine 37 has 2 more neutrons than chlorine 35. I know that because its mass number, 37, is 2 more than the chlorine 35 mass number. So along with that, let's go and ask ourselves, how many neutrons do each of these isotopes have? So how many neutrons would be in a chlorine 37 atom, how many in a chlorine 35? Well, if we think about chlorine, both of these atoms, as we said before, have 17 protons. So if I just do some subtraction, Chlorine 37 would have 20 neutrons because its mass number is 37. And remember, that's the protons plus the neutrons minus the 17 protons. That will give you 20 neutrons. And then if I do the same thing for chlorine 35, that would give me 18 neutrons. Some review questions here to consider. Again, pause the video after each question and then play and see if you got the right answer. Question number 1, true or false? Atoms of the same element must be identical. This statement here is false because atoms of the same element do not have to be identical. While atoms of the same element, they do have to have the same number of protons. They may contain different numbers of neutrons. Question 2, what is the term for atoms of the same element with different numbers of neutrons? Atoms of the same element with different numbers of neutrons are called isotopes. Question number 3, what is a mass number? The mass number of an atom is the number of protons plus the number of neutrons in the nucleus. Question number 4, write the symbol for an iron atom with 30 neutrons. So looking at your periodic table there, you will see iron has 26 protons. So 26 protons plus 30 neutrons gives you 56 for the mass number. So the symbol you can see would be written as such. The symbol for iron is Fe, and we put the mass number there as a superscript on the left side. And finally, last question, how many protons and neutrons would be in an atom of aluminum 27? Looking at the periodic table, you will see that the atomic number of aluminum is 13, so it would have 13 protons. And then in order to get to a mass number of 27, we would need 14 neutrons because 27 minus 13 would give us 14. So 13 protons and 14 neutrons. So taking a look at our learning targets again, we have defined the terms atomic number from the previous lesson, mass number, and isotope in this lesson. The next one, or maybe not the next one, a couple more, we'll hit up that valence electron. And we also starting to look at using proper chemical notation for describing atomic structure.